Hey, good morning. I guess, good afternoon. We're just going to go, I'm going to go quickly through section 2.9. 2.9 is about some order of operations and use it like just speech and things like that. Talk about operators and objects, okay, and recognize. So it's kind of building on what we've been doing. All right, so for this first Explorer question, says complete the table by filling in the missing boxes. Write the operations in words, not symbols. The first line has been completed. Here's the expression, square root of 17. The object is 17. The operation is square root. The square root sign is an operator, okay? We are telling you, hey, here's this number 17. Perform the operation of a square root, all right? So here I got 4 2/5. The objects are 4 and that fraction 2/5. Well, what's going on between those two? It's addition. I'm just adding those two. There isn't an operator in there, but there is an operation. All right. Same idea with the second one here. Okay. 8 over 9, or 8 ninths, 8 divided by 9. Oh, I just said it. It's division. All right. So I'm taking the absolute value of a number here. What is that number? My object is negative 10. All right, I'm going to pause it here. Try to fill out E, F, and G. Go ahead. All right, so E, negative 8's in parentheses. All right, so the object is negative 8. F is a little bit different. Okay, technically this is negative 1 times 8 squared. That's why I tell you to put parentheses around negative numbers when you're squaring them in a calculator or on Desmos or whatever. Okay, because technically this is what this means. So the operation, the object is 8. 8 is the object. Okay, and I'm just taking the opposite of that. I guess you could say negative 1 is also an object here, but we don't really, mathematicians don't really think of that as negative 1. We just think of it as the opposite. Well, that's maybe not true, but we don't really write down like a negative 1. All right, we just write down other objects. All right, my two objects here are 2 and an x plus y. Okay, here I don't know that I agree that a plus b is the only, or a and b are the only objects. I guess you can make that argument because in the second one, these are the exact same thing. I don't see anything different between these two. Okay, so why 2 is not in this one, I don't know. This one, the book is just looking at the top and looking at addition. This one is looking at division. And I'm going to tell you right now, I don't see a difference between these two. Okay, what operation I see going on here is both of these, addition and division. There's nothing else that could be going on. Here, now there is a difference between these two and J. Okay, J is split up like this, all right, split. So here it is just straight addition. All right, because I'm adding A over 2 plus B over 2. Okay, I don't agree. I don't agree that this is different. Okay, I just don't. All right, I just don't agree. So I'm not even going to bother filling that out. All right. So what is today all about? Here's our discover. All right. Can you use the vector vision to prove a claim or find a counterexample to show a claim is false? And we'll talk about that. Can you determine operations being applied in order to which they are applied for an expression? All right. So let's talk about this. Okay. So this is kind of why I was a little bit, I did not agree with what the book said. Because when I see this 4x plus 1 over 4, okay, because technically this is a binomial, and then that's over a monomial. All right. Monomial is one term. You may remember this from last year, and this is 2 terms. Okay. Binomial, like biannually, if something occurs biannually, that's twice a year. Monomial, I think it's just like mono. If a person gets mono, then that person has mono. I don't know. There's other ways to think of it. I just think of mono is right in there, so for sure. Okay, so what else? What's next? So when you see something like this, if it's a binomial divided by a monomial like that, all right, 2 terms divided by 1. Okay, as long as there's only 1 in the denominator like this. I can split it like this. So it's 4x over 4 plus 1 over 4. Well, why would we do that? I would do that to simplify because the 4's will cancel out, so it's just x plus 1/4. That's a little bit easier to do, all right, mathematically. That's a little bit easier on ourselves. Okay, same idea here with part A. We're not going to do part B. B and C are very, very similar. In part A, I can split this because I have 2 terms on the top and only 1 on the bottom. Okay, I can split this as 7x over 7 plus 7 over 7. 7's cancel, I just have x. 7 over 7, any number over itself is just 1. So that's a simplified expression. If this was 6 over 6, it would be 1. If it was 100 over 100, it would be 1. Okay. Next one, still want to split it since I have a single term in the bottom in my denominator. So I'm going to keep that negative with the x, like that. And then minus, I want to change my mind here. I'm going to rewrite this as -1 times x minus 7. Okay, so this is negative x, and this becomes positive 7. All right, I could have written it as minus -7 over 7, but the 2 negatives would become 1 big. I had to think about that for a minute, how I wanted to explain that. All right, so technically this is -1 times x minus 7. I take the opposite of x and I take the opposite of -7, and it becomes positive. So if I keep going, negative x over 7, that would just be plus 1. And that's simplified. Told you we were going to fly through today. All right, so this is an important fact to remember. Examples are not enough to prove something, but just one counterexample is enough to disprove something. So are the following expressions equal? 2 over a plus b and 2 over a plus 2 over b. Okay, if they are, show why. If not, provide a counterexample. Well, this goes back to here. I had a binomial divided by a monomial, 2 over 1. Here I have 1 over 2. If there are 2 terms in the denominator, you cannot split it. Right? I cannot split this. So a counterexample would be, what if A equals 1 and B equals 1? Then I would have 2 over 1 plus 1, which would be 2 over 2, which would be 1. Well, if I plug that into here, I'd have 2 over 1 plus 2 over 1, which would equal 2 plus 2, which would equal 4. So these 1 does not equal 4. So there's our counterexample right there. Could you have picked any number? Yes, I could have picked 10, and still it would not have worked. All right, I just chose 1 because 1 is just a really easy number to pick. Okay, can an exponent be distributed over to addition? In other words, is a plus b squared equivalent to a squared plus b squared? If not, provide a counterexample. Well, this is a very common mistake that a lot of people make. They just distribute exponents. You cannot distribute exponents. All right, I'm going to show you a little something here. If I do 3 squared, what is 3 squared? It's 3 times 3, which is 9. Okay? If I do 4 squared, well, 4 squared is literally 4 times 4 to get 16. So if I have a plus b squared, well, a plus b squared is going to be a plus b times a plus b. It's the same idea. Just because we're using variables doesn't mean I can just get rid of this idea. If I square something, that means I have to write it twice. All right, and so once I do this, well, this is kind of a review from yesterday, all right, or last class, I need to FOIL this. And I would get a squared plus a times b plus a times b plus b squared. So that's 2ab if I combine these like terms here. So this does not equal a squared plus b squared. All right, so there's our counterexample. I just showed you why. Why? Because when I actually multiply this out and FOIL this out, this is my answer. It's not a squared plus b squared. You're missing the middle, which is a very important part. All right, so the connection, it gave you this long thing to do. We're gonna skip over that. I talked about sealing an envelope. Okay, we're gonna skip over that and go to this last one here. Evaluate the expression when n equals 5. It says list the operations, but we're not going to do that. I just want you to evaluate it. So if I plug in 5 for n, whoops. What am I going to do first? All right, remember PEMDAS. PEMDAS says I got to do the exponents. So really that's 3 times 25 minus 2. All right, so a lot of us would just multiply 3 times 5 and say that's 15 squared. That's not 15 squared. You got to do the exponents first. Don't forget your order of operations. Okay. Last one, 2 times 5 minus 1. Remember, PEMDAS, parentheses first. 5 minus 1 is 4. So that's 8 over 3. And I can just leave it like that. Okay, it's technically 2.6 repeating. But we'll just leave it like that. All right, that's it for today. I thought it was pretty short. There you go.